Okay, this week we are going to be looking at energy, work and power. But to start this off, we have to know what is energy. So to answer this question, there's essentially two main types of energy. There is kinetic energy and there is potential energy. Kinetic energy is the energy that an object has because of its movement, whereas potential energy is energy which has been stored, or the energy that an object has because of its interaction with other objects. So essentially, energy is either movement or the potential to create movement. We can explore each of these two categories in more detail. So the first type of kinetic energy is translational kinetic energy. This is the energy that an object has due to its bulk movement. So for example, if there was a tennis ball that was moving in this direction, the entire tennis ball is moving in that linear direction, and so it has translational kinetic energy. The next type of kinetic energy is thermal energy. Thermal energy is the kinetic energy that an object has because all of the little particles that make up that object, usually called atoms or molecules, are vibrating around and moving. So, for example, let's suppose we zoomed in on that tennis ball and looked at the bottom bit of it. That tennis ball is actually made of lots of tiny little particles, and each of these particles is moving around backwards and forwards, vibrating. And so the vibration of these is the thermal energy, and the faster that these are vibrating, the higher the temperature of that object will be. And the last type of kinetic energy that we will look at is rotational kinetic energy. This is the energy that an object has because of its rotation. So for example, imagine that we looked at the tennis ball and it is spinning as it moves through the air. So in this case, the tennis ball does have translational kinetic energy because it's moving towards the right, but it's also rotating. It has some additional energy. So that's because the particles at the front here would be moving down this way, the particles at the back would be moving up this way, particles at the top moving around. So the extra energy that it has because of this rotation is called the rotational kinetic energy. Now let's have a look at some types of potential energy. There are lots of different types of potential energy out there, but we're going to only look at a few of them. The first we're going to look at is chemical potential energy. Chemical potential energy is really an area of study in itself, so it can be quite complicated. But in short, it's the energy stored in chemical bonds between different atoms. Some examples of chemical energy include the energy that's stored in food that we eat, the energy that's stored in human fat and muscles, and the energy that is stored in petrol that's used in cars. The next type of energy we'll look at is gravitational potential energy. This is the energy that an object has stored because of its position relative to other masses. So the main case we're going to look at is the Earth. So if there's an object which is raised above the ground, then gravity has the potential to pull it down and create kinetic energy. So this ball here would have gravitational potential energy. This ball here, which is on the ground, we would say does not have gravitational potential energy. However, it's actually a bit more complicated than this, because, for example, imagine that there is a cliff like this underneath the first ball. Now this ball is on the ground, so does it have gravitational potential energy? Well, the answer is yes, if it will fall down to this lower height down there. So really, we don't care if an object has gravitational potential energy or not. All we care about is the changes in gravitational potential energy as an object moves from one height to another height. The last type of potential energy that we're going to look at in detail is called elastic potential energy. This is also called spring energy sometimes. So this is the energy that is stored in a spring or a rubber band or anything like that when it is stretched or compressed. Now there are many other types of energy out there, and you can have a look at these yourself, and you're no doubt going to encounter them in your physics studies. But before we move on, there's three equations out of all these that I would like you to know. So the first one is the gravitational potential energy on Earth is given by the following formula. So mass times the acceleration due to gravity, which is 9.8 meters per second, times the height of the object. Now really, we only care about changes in gravitational potential energy, so what we can change this to is delta GPE equals mg delta h, change in height. The next type of energy that will be important for you to know is kinetic energy. So the kinetic energy is given by half mv squared, and the final one is the elastic potential energy is given by, where k is the spring constant, a measure of how much force is required to stretch the spring by 1 meter. And so the units is newtons per meter. Delta x is the distance by which it has been stretched or compressed. Now note, each of these formulas is actually only an approximation. None of them is perfect. So the GPE that I've shown you here only works when you're on the surface of planet Earth. If you move into space or move a large distance away from planets, you need a more complicated formula. Similarly, our kinetic energy only works when you're moving slowly compared to the speed of light. If you move significantly faster than this, then this formula no longer works. And elastic potential energy formula that I've shown you only works for a perfect spring. That is a spring which force is given by the following formula.